this voice,
this music, this image, this video, this text, all made by a machine. Artificial intelligence is dominating the planet, and you need to know about it. This is a comprehensive crash course on AI generation for beginners. On my channel, I've generated thousands of AI images I've put into my videos. I use a model called Stable Diffusion, which is based on the Latent Diffusion model. Latent Diffusion has three parts: a VAE, a UNet, and a text encoder. The VAE has two parts, an encoder and a decoder. During the latent diffusion training, the encoder shrinks the image into a low-dimensional version, called a latent. This makes computation simpler and take up less memory, enabling us to generate large images quickly. The decoder, on the other hand, reverses the encoder's work and turns the latent representations into full images. This process will be vital in the steps ahead. Then comes the UNet, which simply predicts the clean image from noisy inputs. If you're wondering what noisy means, it's not this, it's this. On the other hand, the text encoder converts the given prompt into code that the UNet can use to clean up the image. In Stable Diffusion, instead of training a new text encoder model, they use one that's already trained, CLIP. Another more old-fashioned approach is GANs, or General Adversarial Networks. This model is comprised of a generator and a discriminator. The discriminator tells if an image is real or fake. Simply put, the generator tries to fool the discriminator. The discriminator takes two kinds of inputs: real images, the positive inputs, and instances created by the generator, the negative inputs. As seen in the figure shown, the discriminator loss penalizes the discriminator for classifying an image wrong. The discriminator then adjusts its settings to try and get the classification of the next image correct through a method called backpropagation. Backpropagation employs an optimization algorithm called gradient descent and calculus's chain rule to calculate how much a parameter in the network contributed to the error.
What the Sigma?
But that's all complicated, so I won't get into the details here. I'm sure by now you are beginning to wonder how ChatGPT works. The GPT in ChatGPT stands for Generative Pre-trained Transformer. Transformers are gaining popularity rapidly in the realm of NLP, or natural language processing, and are outshadowing other models popular just 5 years ago, such as CNNs or RNNs. Here's how they work. Simply put, transformers turn an input into an output, which they do by learning relationships between parts of a sequence. For instance, if you were to ask it, "What color is the sky?" the model would identify the relationship between the words color, sky, and blue, and give the output, "The sky is blue." At the heart of transformers is their self-attention mechanism. Instead of processing data in order, they look at different parts of the sequence and determine which parts are more important. And this all happens at the same time. Wow, that was a lot to process. We covered Stable Diffusion, General Adversarial Networks, Transformers, and everything in between. Now that you know a bit more about what's going on behind the scenes, let's look at some practical applications of this mind-bending technology. For example, Google has been working on setting up wildlife cameras and using AI trained on the models we just covered to identify the species being photographed to gather information about the species and their populations. Without this tool, humans would have to manually filter through millions of images, which takes a lot of time. Another example is AI being used to find chemical compounds that would be beneficial in prescription drugs. But there is a flip side. AI also has the potential to be used for bad, as killer robots with 100% accuracy, or posting fake controversial photos online. The possibilities are endless. On that happy note, we end the video. If you enjoyed it, please consider subscribing for more explanations just like this. Thanks.